Section 6.1, example 3, representing a function with the power series. So use a power series to represent each of the following functions f of x. Find the interval of convergence. All right, so starting off with this very first one. This is modeled very similarly to the geometric sequence. So geometric sequence tells us that the infinite sum is equal to the first value of that sequence divided by 1 minus r. We're going to mimic that right here. So looking at this, we could turn this into a geometric sum. So going 1 minus negative x cubed. And we're dividing that by 1. So now looking at this, we could easily switch this to the sum. So we'll say s of x in terms of x. And this is going to be the sum as n goes from 0 to infinity. And we start off with the very first term here. The first term is going to be 1. And we multiply by the ratio, which is a negative x cubed to the power n. And there we go. This is what our sum is going to look like. And we'll start our interval of convergence. So instead of writing out interval of convergence, I'm just going to do IOC, interval of convergence. Here, in order for this to be an infinite sum, this value has to be less than 1. So what we're going to do is say that the absolute value of negative x cubed is less than 1. So this is going to force it to be from negative 1 x cubed all the way up to 1, which is just negative 1 to 1. So our interval of convergence is going to be from negative 1 up to 1. And there we go. So for all values x belonging to this, so the way that we could write it shorthand is x belonging to this set of values. So for these values, we have this function here converging, which I think is pretty cool. All right, so moving on from here, let's take a look at this other one. Part B. How do we make this look like a function like we did over here? So one, we could start off with our numerator, our a1. Most importantly, we have 1 minus and then some value over here. So let's make that, or this, look like that. So we have f of x equal to, I'm going to factor out a 1 over 4 just to make this value here 1. And then factoring out that 1 over 4 is going to make this x over 4, or x squared over 4. And in the numerator, we have that x squared. Let's fix this one more time. The denominator, we have 1 minus x squared over 4. And in the numerator, we have x squared over 4. And now that we have it in the proper form, we could actually use that to find our sum. So our infinite sum, our sum with respect to x, goes from n going from 0 to infinity. And our first term is this right here, x squared over 4. Our common ratio is x squared over 4 to the power n. And it looks like we're good here. So now we have to look for the interval of convergence. So the interval of convergence is this value being between 0 and 1, or we could think of the absolute value of x squared over 4 being less than 1, because all of those numbers are going to be positive and greater than 0. So we have from negative 1 less than x squared over 4 less than 1. And we have negative 4 Doesn't look like this is going to work in the negative spectrum, so it has to be all of the positive values. So instead of -1, we'll go from 0. So 0 less than or equal to, or less than x squared, less than 4. We end up with the values that make this true are going to be from -2 all the way up to 2. All right, and we could say that x belongs to the set of values from -2 up to 2. And there we go. That is our interval of convergence. If you have any questions, please feel free to ask. Otherwise, bye.